So in this video we're looking at prisms. Prisms are very, very cool. You've seen them on the cover of Pink Floyd album, Dark Side of the Moon. And okay, you might not have seen that depending on how old you are and what your musical tastes are. Go look it up, Pink Floyd. Anyway, the two aspects of prisms that we need to look at, one is dispersion, which is when you see a rainbow, a raindrop is acting like a prism, and the other is total internal reflection, which is using a prism in such a way as to reflect light. Just kind of cool. So what is a prism? Prism is a piece of glass that's shaped in a triangle or rectangle. No, not a rectangle, it's a triangle. Where did that come from? I don't know. And it's, if we're drawing it in sort of a three-dimensional kind of thing, there is a, this is very difficult to draw, but this is an end, and then this is sort of a side, if you like. Okay, I'm not going to use this. You have 90-degree prisms, and you have 60-degree prisms, and they're just using refraction and geometry to good effect to produce interesting effects. Okay, so let's go and have a look. First of all, we'll look at a 60-degree prism, which means it's got 60 degrees here, 60 degrees here, and 60 degrees here to make up that triangular shape. Internal angles of a triangle adding to 180 degrees, that sort of thing. Now, just put that out of the way. We've got, we want to illustrate dispersion here, which is when your prism takes, I don't know how I'm going to draw this, maybe, I've got a great idea. I'm going to stick a black square down. I'm afraid I don't know how to move that to the back, so I'm just going to try drawing a triangle on top of it. I don't think I can have a triangle on here. Oh no. Alright, I'll draw a white, no I won't. I'll draw a blue triangle on top of this. See how this goes. Yes, perfect, that's what we're after. And this way I can show you white light coming in. Okay, there's our white light coming in, and we have a normal at that boundary, and what we're going to notice is that at this first boundary the light rays they've been towards the normal, coming into the into there, so they're going to start spreading out. So you'll be I'll just draw three rays to show that each of the different colours within the within this prism, no it's not, it's a light ray going in, they each start to bend slightly different amounts because they have a different refractive index for each colour of the light, of the glass. Now that's very interesting. It's because they have a different speed and a different wavelength for each. The frequency, remember, stays constant. And then at the next boundary we've also got this normal, but this time they're going to bend away from the normal, and we'll get even more dispersion. So my normal there is just a sort of an average position, so we're going to get even more dispersion, bending away from the normal, which is in that direction. Previously towards the normal was in that direction, so this is like the top half of a concave converging mirror lens. Anyway, you know where I'm going at with this. So Roy G. Biv, it's going to separate all the colours out really nicely. Red, orange, yellow. They would be continuous though. I'm drawing them separate just for the sake of being able to draw them comfortably. Blue, and I'm just going to cut straight to violet. I know there's an indigo according to popular theory, and you can see that red light refracts the least, so they've got least, L-E-A-S-T, least refraction from the red, and the most refraction from the violet or purple. Okay, and it's interesting to note as well that there will be other, you know, the infrared and the ultraviolet spectrum that's dispersed in this way. It's very, very cool. Very cool concept, very useful, very interesting. The other phenomena which you might come across in physics which does this is a diffraction grating, which is like photographic film with a whole lot of very miniature small lines like a grill, and the light when it goes through acts as a wave, and you have interference patterns which produce the spectrum. Okay, so that's a 60-degree prism. I think you can get the same effect with a 90-degree prism, but I think it tends to work better with a 60-degree because of the larger angle, but I don't know exactly why. Now, moving on, we're going to go to our 90-degree prism in this case, and we're going to set it up like so. So it's 90-degree prism because of that 90-degree angle. And we're going to take our light and we're going to send it in here, directly along where the normal would be. So it's going to pass straight through with no bending. It hits this back surface, and because this angle here will be greater, it has to be at least 45 degrees, it's usually greater than the critical angle, so you get total internal reflection and then passing straight through on the way out. Okay, so that's how it works, and yeah, periscopes work this way. Let's see if we can shrink this down and turn it into a periscope. So you can then have one set up this way. Oops, I haven't drawn it very well. And you get total internal reflection again occurring at this point, and you can look at it here. You can extend this length as much as you like, and you can see an object sitting up here. Let's see, the only problem is you may, oh no, because you won't actually, because you've got two mirrors, the typical lateral inversion, or the way this is set up, vertical inversion that you see, it happens twice, once at here and second time there, so you actually see it up the right way, which is really good. Also very useful in binoculars. Where did that come from, you might say? These are my very rough binoculars, where you might have light rays coming in, and you want to keep them compact, so you want to have a very limited length of your binoculars. So what you can do is you can use prisms to bounce the rays back and forth. Where are we? There's another one. Back and forth to give you a little bit more length before it comes out into your eyes, and you can stick your lenses in certain places and at the end and all sorts to be able to effectively get a longer length between the lenses. So that's quite useful, very cool engineering principle, and that's where the cool physics really comes into it, I think. Okay, so that was Prisms. That's our Pink Floyd album cover. They were prisms, and we're looking at dispersion and total internal reflection to make periscopes and other cool things.